Okay, here we go.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning. This is the May meeting of the DBA Fundamental Virtual Chapter for PASS. I know that I had said on our email that we were going to be doing something 20 minutes before and show up early. Well, I had technical difficulties, so I decided not to mess with anything at this point and just go ahead and go with the presentation as is. But what we'll do next time is we'll pick a video from a speaker, a short video, 10, 15, 20 minutes on one specific topic, and we'll show that for people that like to show up early. And you can ask questions, and the speaker won't be available online, obviously, but he or she will have agreed to, before I show it, answer the questions in either a blog or directly on our site. So anyway, back to the main event. Today's presentation is entitled XML Without XANAX, How to Handle XML in SQL Server. It's going to be presented by Adam Belebchik, and I'll be turning things over to Adam in a minute, but I want to bring a few things to your attention first. First, we'd like to thank the Professional Association of SQL Server for supporting DBA Fundamentals chapter. There are a lot of other virtual chapters out there. I'm not going to show you a list of them. You can easily go to SQLpass and .org and navigate to the virtual chapters, join up, and there's a chapter there for every possible thing that you might be interested in on SQL. And there's lots of great presentations out there, so check out all the other chapters too. My name is Steve Cantrell, and I'm the chapter co-vice president. You can send us questions if you want to by going to our About Us tab at fundamentals.sqlpass.org. Summit 2015 is going to be in Seattle again this year, October the 26th through the 30th. And you can save $150 if you use our discount code VC15GBQ6. Thank you, Adam. And so for people to see it. I think there's a cutoff date in July, so you might want to watch that if you are planning on going, to where there's either a $300 or $400 price increase after it goes past that point. So you probably want to be making decisions before then, because if you combine that, you can get $550. You can get it from other virtual chapters too, but hopefully you'll do it from ours. Next month, we're going to have Grant Fritchie, a Scary DBA, presenting a session called Identifying Long-Running Queries. We had one in production yesterday, and believe me, it's not fun to deal with, and hopefully Grant can provide a lot of techniques and ideas as to how to work with those. In July, we're going to have a presentation by Mickey Stewie called SSRS 101. She'll go over a few things that you need to do on installation, configuration, and setup, and how to actually utilize it. When I first started out as a DBA, I had to deal with a SSRS setup, and it's not extremely hard, but it would have been nice to have had a refresher or a little beginning talk like this to be able to handle it. That's all the housekeeping I can think of at the moment, so let's get started. We've got, again, as I said before, Adam Belebchik presenting XML Without XANAX. Adam is the owner and principal consultant for Adam Belebchik and Associates Consulting, and has over a decade of experience working with platforms such as Microsoft SQL Server. I'm not going to read all of that. Basically, he'll have that on
I don't think that's even my bio.
Oh, is it?
I don't own a consulting firm.
Wow. Okay.
That's
Well, it's
awesome.
good
No,
I didn't finish reading
own a
it
consulting
then.
firm.
Okay. Okay, so you don't have a consulting group. I'll let you present it correctly then. So I'm going to turn it over to you.
Thank you, Steve. So before I talk about myself, let's go through a little intro here. So who feels like this Lego guy on the screen when you think about XML in your SQL Server? Does XML make you sad? Does it make you depressed? Maybe frustrated? Maybe even angry or ticked off? Does it make your head explode? Does it make your server explode? Does it bring your performance to a screeching halt? Does it slow it down? Do you have problems with slow-running queries when you're parsing XML? Well, by the end of this session today, you're not going to become a superhero when it comes to dealing with XML in your SQL Server. What I'm hoping will happen is that you'll become a cool cat. Whoops, a cool cat, and have some tools in your tool belt on how to handle XML in your SQL Server. So my name is Adam Bolubchak, as Steve mentioned, and I don't own a consulting firm. That would be fantastic if I did. Instead, I am a consultant with Highland Software, the creators of OnBase. I've been in IT for a little over 10 years, doing all kinds of things from development, network and systems administration, etc. But my focus is really on SQL Server development and performance tuning. I'm the chapter leader for the Ohio North SQL Server Users Group, and I've got some certifications that you can read and be impressed by or not. That is totally up to you. At the end of the slide here, you see my contact information, Twitter, my blog, my email. Don't worry about jotting that down just yet. I'll show it again at the end of the session, but it's there for you to ask any questions or to follow up on. I'll also have a link for resources at the end of the slide, or end of the slide deck, for how to get the presentation files and the demos, and just other miscellaneous resources for this session. I believe that Steve will also be posting those on the DBAFundamentals website for you too. So when it comes to dealing with XML, what are our fears? What prevents us from working with it or getting used to it or being okay with it? And it really comes down to kind of four things here. It comes down to maybe I just don't understand this XML thing. It's different than relational data. It's something that I'm not used to or not familiar with. Or maybe I don't know how to generate it. Maybe I've got this awesome result set that I put together that's exactly what I need, but now I need to hand it off to somebody else as XML, and I'm not sure how to do that. Or maybe the other end of that's happened, or the other side of that. Maybe I have this XML that I received from someone else or somewhere else, and I don't know how to turn that back into relational data and how to consume that within SQL Server. And then finally, maybe I'm worried about performance. Maybe I've tried it before and it's slow, or it's chowing down all the CPU on my server or all the memory, and I'm worried about performance. And then I'll add a fifth one here. This is probably my favorite. It's the, damn it, Jim, I'm a DBA, not a developer. So you have to put on your developer hat a little bit when you're talking about XML and step a little bit outside the relational world of databases. So it's a bit outside our comfort zone, and I get that. I do. It's understandable, but it can be a really powerful tool for transporting data and for talking to different services, and also we'll see here when we look at the use cases for a few different things. Specifically, extended events. So if you haven't already heard, SQL 2012, as of that version, the SQL trace tool that we all know and love and use all the time, it's considered deprecated. So it's not dead yet, but there's a bullseye on its back. It's going to go away pretty soon. To replace that, Microsoft created extended events, which are a series of points in the code of SQL Server that will trigger it to log an event, essentially, and it's how we can capture information like deadlock graphs, like performance metrics, and all kinds of those things that we would do with SQL Trace, but also way more information. Things like always-on information, and things that you just can't do with SQL Trace, you can do with extended events. So one of the ways that we capture that data is with we can save it to XML, and so then what that allows us to do is kind of archive off. Think of that almost like a trace file. You can have it create XML files. And so one of the things we'll need to do is parse that XML to then get useful information back and see in a more user-friendly format what we're actually dealing with in those results, and maybe even to aggregate some of it. So that's one use case for XML and why it might be important in SQL Server, and perhaps maybe the most important reason. Another good use case here, or a reason for dealing with it, is let's say you have sparse or unstructured data. So essentially we have a lot of different pieces of data we may or may not collect about something. You do have sparse columns in SQL Server, so you could certainly have a table that's 4,000 columns wide, and they're all sparse columns, and you just populate the ones that you want. But do you really want to do that? An alternative is you can have an XML document in one column be kind of where you collect that information to, and so each individual row that has this XML document may have content in that XML document that's totally different and totally a different schema even than what's in the next row or the row after that. A good example of this is I worked as a systems administrator for a number of years, and there was a product called Altiris Asset Management that's now the semantic management platform. What it would do is it would audit your computers, your servers, your network equipment. You could even manually key in information about desks and chairs and cell phones and desk phones and pretty much any kind of an asset you'd want to track, even software and licenses. But it was all tracked and held in a common set of tables, all that information. So there would be some things that were in common, some things like maybe make and model and serial number. Those are on almost all of those asset types. But what about something like number of CPUs or amount of RAM? Is my desk really going to have 8 gigs of RAM? Probably not. I don't think I have that fancy of a desk. So that might be something I don't want to track on every asset, and I don't want it to be part of the hard-coded table structure in my database. Instead, those additional fields that are, in this case, they were even user configurable, so I could add on a field if I wanted to that had some special meaning to me. I don't want to have my application constantly changing the schema of the database to track all of that. So instead, XML is a flexible way that I can do that. So I simply just adjust the format of the XML that I'm storing and put the data in there and save it off into one little column that's my inventory data. And now I've handled this kind of sparse or unstructured data in a much cleaner fashion within SQL Server. Another use case is data from third parties. So things like web services, API calls, Google, Bing Maps, etc. I would argue probably that your application is a better place to do this because your application is probably what's going to be talking directly to these web services and APIs. But if by some chance you're maybe, let's say archiving off the results that you get from an API, because usually when you're talking to one of these web services or APIs, you're getting back either like JSON data or XML or some other format of data. And if it happens to be XML, you could, if you wanted to, write that straight into a database and then let SQL Server parse the information out. That's an option. Again, I would probably argue that the application doing that would be more efficient and a better way to do it. But let's just say you did archive it into your database. And then later on you wanted to get some information out of that. So you would need to have some tools and some ways that you can query that information in SQL Server to do that. And then finally is Service Broker. And Service Broker is a good friend of mine that is often overlooked in SQL Server. It's been around since, I believe, SQL Server 2005. And it's essentially an asynchronous messaging system built into SQL. It's a way for me to send information from one database to another, whether that's on the same instance or whether it's in another instance that I control, or maybe even it's another instance that I don't control, like a customer or vendor or third party of some kind. What's really cool about it is it handles all the message delivery and retry logic if something goes wrong. It handles all of that for me. And essentially I just fire off a message and then the rest it takes care of asynchronously, kind of behind the scenes, while I continue on with running my queries and doing what I would normally do. Why XML comes into play here is because the message you're sending is typically going to be an XML document. It's typically XML data that you're sending from one instance to another, so that when you send that message and it's received on the other side, they can parse that message, get back the data, and use it in some meaningful way. So again, these are some common use cases for having XML in your SQL Server. But XML isn't perfect. It has some problems. One of them is that it's stored as a lob or a large object or a binary large object, and this should make you sad. Essentially, because it takes a certain number of IOs to get to a row of data on a particular page in your table or your index, and that would be great if XML was in that page, but it's not. So if I have a row of data with a column that's XML, I have to now navigate down through the index to get to my page, read the row, which has a pointer on it that says, hey, there's this XML that's hosted over here somewhere, go get it. And so then you have to go off the page, retrieve that data, and then now you have the XML document. So it introduces additional I/O that has to happen, and that can be painful. In addition, it requires a different set of tools, a different way to query this, different syntax than relational data, and that's called XQuery. There is another method, it's called OpenXML, but that is, I would almost consider it deprecated. It's not officially, but it's something that I wouldn't recommend using any longer. Now, if you're stuck in SQL 2000, or I think maybe even 2005, then you might have to use OpenXML. But if you're on a fairly recent version of SQL Server, you should have access to XQuery and all of its tools and methods. It can also be difficult to parse for the server. So that was difficult for me, right? The query, the language and syntax, but it's difficult for the server too. It has to parse that document first to some kind of intermediate format that it can understand, and that process is pretty CPU intensive, can be a little bit memory intensive as well, and it can slow things down. Now there are some things that you can do to alleviate some of that slowdown or some of that stress on your system, like XML indexes that we'll talk about a little bit later. But just keep in mind that it is something, it's a little bit more intensive to query XML than it would be to query just a table in your database. And thereby, the final bullet point here, it's hard to aggregate XML values as well, because you can't use a, you don't have the ability to just have an index over a column and use all the nice tricks that SQL does with data in a relational manner, or in a using set-based logic. It's very rebar. It's very row by agonizing row. So if I wanted to take a 100 million row table that had an XML column and aggregate all those rows together to give me, say, a summation of, say, index or invoice data. Let's say that column in my table was storing an invoice information. So I had, say, like an invoice total, and I wanted to say, how much, what's the grand total of this entire table? Just doing that one sum over all those rows, it could take hours. It's going to take a long time, because it has to parse each individual document, retrieve that particular value that you're aggregating, and then perform the aggregation as well. So it's very resource intensive and painful to do aggregations on XML. So if you have to do that, what I would recommend doing is actually staging out those values in kind of another process ahead of time before you're doing your aggregation, and putting those values into an actual table column. Because then at that point, A, you can use set-based logic, and B, you can index that column as well, and that makes your aggregates much, much more efficient than if you were going to aggregate straight from XML data. So, what does XML look like? So here we've got on the right-hand side an XML document. It is considered well-formed, and I'll explain what that means and why here in just a second. The XML document that you see there is made up of some different parts. So the whole thing you're looking at, that's the document. So it's all of the different elements and attributes and all of that stuff you see there. That is an XML document. An element is simply what's between a tag. So think of XML a lot like HTML. And if you're familiar with HTML, it's essentially a standard language. It stands for HTML stands for Hypertext Markup Language. And a markup language is basically a descriptive language, or how something is viewed. And so it's saying how hypertext is viewed. It's defining the the information that you see in a web page, essentially. But it's a standard. It's something that a lot of people took a lot of time to come together and build a set way to do something. And so with HTML, you have a set collection of tags that you can use. You've got a body tag, for instance, or a title tag, or a P for paragraph, or a B for bold. Those are predefined tags that are defined by that standard that you can use. With XML, XML stands for extensible markup language. So it's extendable, or it's customizable. It's whatever I want it to be. There is a standard behind it, and that's why you see this XML version equals 1.0. That's saying what version of the XML standard this document uses. But that standard has just a few rules in it that define what a valid XML document is. And it's things like any given element name cannot start with a number. It has to start with a letter. You know, there's just some formatting rules that are there to keep things kind of sane and logical. But it doesn't define what, say, you know, for instance, my invoices tag. It doesn't define what this means. It doesn't define that there has to be one. It doesn't define the meaning of it. That's up to me, and I can specify that myself. So that's what makes XML powerful, is I can on the fly define what this document looks like and what the meaning is for any given part of the document. So if we're taking a look at this, and let me start a pen drawing here. If we're talking about an element would be this here. It would be the invoice and everything that it contains. So invoice, whose ID is 123, that is one element of my document. And it sits below the element called invoices. So it's a child of the invoices element. And each element is essentially a tag. So what defines a tag is it has this less than sign and a greater than sign on the end. And so that's the starting or opening tag. And then down here we've got the closing tag. And how I know it's a closing tag is the / So any tag with a / is simply closing up that tag, or it's ending the element. And when I ask you what is the what's the value of, let's say, this element that I've drawn a box around of the invoice whose ID is 123, what's the value of that element? The value is going to be the contents, everything in between the beginning and ending tag. So it would actually be the line items that you see here. That's the value of this invoices element, or this invoice element rather. And if I were going to ask you again what the value of this first line item is, it would be widget, because that's what's in between the line item starting and closing tag. So you can see how XML is essentially a big hierarchy of elements that have values, and those values can be other elements that can then have other elements and so on and so forth, until you eventually get down to a level where you're getting actual data. It can be text, it can be numbers, you know, just about whatever you're wanting to see there. And so that's how you know, the basis for an XML document is it's a hierarchy of elements that are describing essentially some data that you have. Now we also have this other concept called attributes. And so attributes are properties that describe the elements. So in this case, ID equals 123, that's an attribute or a property that describes my invoice. So this invoice element is for invoice number 123 or ID number 123. Just like for this line item down here, it's saying that this line item's ID is for COG or COG. So that's describing this element. And typically the way that XML is structured, but again it's very stylistic, it's up to you. You can define how this is built on your own. But what most people do with XML is they use the elements to describe entities of some kind of an object. So for example, an invoice is some kind of a thing, right? I can pick up an invoice. It's a piece of paper maybe. You know, that's a thing. A line item is just a set of information on that invoice about something that has been purchased essentially. So that's another thing. It's an entity. It's an element. And then descriptions of that element or things that modify that element become attributes. So, for example, the number of the invoice should be an attribute. That is a property. It describes the invoice. It belongs as an attribute. You could have things like a status here. You could have maybe an invoice date would be another thing to make as a property or an attribute. You kind of get the idea. So, if I was having, say a hierarchy of employees at a company, I might have my root element, and by the way, a well-formed XML document has one and only one root level, which everything falls below. So you'll notice there's no other There's not another set of the invoices tags, right? There's not another set down here. There's not, because for it to be well formed, there should be only one element at the root level of the document. So that makes it a well-formed document. It's possible to have just simply a document made up of multiple of these root levels. It's just not considered to be well-formed. And in some applications that parse the document will actually throw an error with that. But in other cases, it might be valid. Again, XML is extensible. It can be set up however you want it to be. So I've described kind of the structure of our document and how it's laid out. Let's talk about some other things that go with XML. So we've got XML schemas. And so think of an XML schema definition or an XML schema or an XSD. Those are all just ways of saying the same thing. That is another document. Oddly enough, it's another XML document that describes the format and essentially some validation rules for a set of XML documents. So I could have a schema definition that defines this document, this set of invoices, and what's legitimate or legal or allowed in that document. And it would say things like, for this to be well formed and for it to pass validation, it has to have the root node be called invoices. And then below invoices, you can only have invoice elements, and you have to have at least one of those, but you can have many of them if you want. And each invoice element has to have an ID attribute that's a number. And below the invoice element, you have to have one or more line item elements that have an ID and a value of some kind that's text, and so on and so forth. It's a set of just logic that describes what is valid for an XML document. The idea being is that I can apply that definition to an XML document and get back a result of whether it passed or failed that validation. So I know whether, think of it like a constraint in SQL Server. And I can put a constraint on a column that says that, say it's an integer column, I can say, put a constraint that says that this column value must be greater than 0. And if I try to insert -1, SQL is going to come back with an error and say that's not allowed. Just like that, I can use schema definitions the same way. And if I try to insert in an XML document that doesn't pass validation, SQL Server is going to come back to me and say, no, that's not allowed. You've defined this schema definition as what's valid. This document isn't valid, so I'm going to fail this query that tries to insert invalid data. So that's pretty cool. The other thing that you can do is use style sheets. So style sheets, or XSL style sheets, are a way to transform XML data without actually modifying the XML file. So this comes from actually the HTML world that I was talking about earlier. There was a concept called cascading style sheets. There still is, actually. It's used pretty heavily. That say you go to a website and it allows you to have a user profile of some kind that defines the look and feel of that website. And whenever I go to that website, the background is a nice blue color and the text is black, and it's formatted a way that I've already configured and I like. And then let's say that Steve goes to that website and he sets up that same profile, but he likes the color green instead of blue, and he likes his text to be, I don't know, red instead of black. He can choose that and set those settings up, and what's actually happening when he visits that website and when I visit that website is we're looking at the same exact HTML page on the back end, but we're getting different style sheets applied. There might be a blue background and black text style sheet, and a green background and red text style sheet. And depending on who's coming to the web page, it's going to apply a different style sheet to give a different look and feel to that website. In much the same way, XML style sheets transform XML documents without actually modifying them. So I can have one style sheet that if I had, let's say, like pricing information on here, I could have a style sheet that would sum up that pricing information. So not only can I change the look and feel, like I can maybe rename invoice to purchase order or sales order, and present that to my to my application, and now it looks like these are all sales orders versus invoices. But I can also do calculations, and that's where it's really powerful, is I can apply calculations like sums and averages and your typical addition, multiplication, those sorts of things, to add some additional value to this document that wasn't there by itself. Why I talk about this is not because the database engine uses it. So SQL Server, just the regular database engine, doesn't use style sheets at all. But what does is SSIS, so SQL Server Integration Services, can use style sheets. When you're reading from an XML file, you can apply a style sheet that transforms that XML file to make it easier for SSIS to deal with. So it's useful there, and that's why I mention it. Beyond that, though, it's a bit outside the scope of this talk because we're really talking about the database engine. So there are three main areas in SQL Server in the database engine where we're going to be using XML. One is called for XML, and that's how we generate XML. So we tack that onto the end of our query, and it will tell SQL Server to produce the result set not as a tabular result set, but as an XML document. And we'll take a look at that in just a moment. There are also database objects where I can store XML to be interacted with. So those are things like variables, columns, indexes, and again those schema definitions or schema collections that I talked about. And we'll look at that as part 2 of our demo. And then we'll wrap things up with XQuery. And XQuery is essentially how you read from how you parse an XML document and select from it. Oh, sorry here, my network connection got a little flaky for a second, but I think we're good. So XQuery is essentially it's a standard part of XML. So when they built the XML standard, they also built XQuery, and it's a bunch of methods that allow you to retrieve values or even modify values in XML. And so they're called methods. You'll see why in the demo. They're basically dot methods. So I'll have the column name dot exist or the column name dot value. And what it's saying is take the XML in that column in my database or in that variable and run this method on it. And so we'll get into that in a little bit more depth here when we get into that part of the demo. But essentially you have 5 of them that have been implemented in SQL Server. There are more than that exist in the standard, but Microsoft implemented these 5 because it's what they figured would be most useful to us. So let's take a look at how we generate XML in SQL Server using for XML. So what I have here is I have a database called XML Without XANAX, and it has 2 tables in it. It has an invoice header table and an invoice detail table. So the invoice header table has your typical invoice information. It has the invoice number, the invoice date, when it was what status it is. So if it was delivered, if it's a new order, if it's has been shipped, that sort of thing. It has the customer number and the customer's first and last name. So Lester Tester here, he's our first customer. Jake Fake, he is our second customer. And apparently I am our third customer, SQL Diablo. In addition to that, we also have some pricing information. So we have the invoice's subtotal, the tax amount, the shipping amount, and the total of the invoice altogether. So you'll see here it looks like I'm actually kind of a bit of a big spender here compared to the other guys. Anywho, that's our invoice header table. It has just kind of the overall invoice information. And then now I have my invoice detail table, and this is where for each invoice number I have a set of line items. So in this case it correlates back to my invoice header by invoice number, and so these first 2 rows are for invoice 1. They're the 2 line items. There's a quantity, price, what was bought, how much the unit price was, the discount, so on and so forth. Again, just typical kind of sales order or invoice information. So that's what we're going to be using to set up these demos. And so I can run just a regular select statement. I only highlighted part of it on purpose here, and that'll give me back your regular kind of tabular result set like you're used to seeing, right? But what if I want to get that as XML? I can tack on to the end of it this for XML command, and it takes some additional parameters essentially. And to me, the parameters are actually kind of out of order. I would expect to see root listed first, but if I did that, it would error out. So you have to start with path, and path is saying for each row that comes back in this result set, what is going to be the name of the element that I wrap around that row? And then going up a level, it's saying what's the root element of the document. So just like kind of the example we were looking at in the slide deck, invoices, that's our root element. And below invoices, we have one or more invoice element. And then each invoice element is a row from our table. And in addition to that, each of our columns from our table, those are going to become elements as well. So if I run this, we're going to see we get back a result set of one result, but it's got this kind of hyperlink thing that I can click on, and that's our XML that we get back. And so now we see, I'm going to shrink down some of the other lines just to make it easier to read. Those are the second, third, fourth, and fifth invoices. Here's the first invoice that we were looking at. And just like our example, we had invoices as the root, invoice below that. But now where it's a little bit different is each column is now its own element. And so now we're getting back, invoice number with a value of 1, invoice date, and there's our date of the invoice, the status, and so on and so forth. So that's a quick and easy way on how to get our relational data into this kind of hierarchical XML format. But we can get a little bit fancier than that. So if we scroll down a little bit here, now we can define the structure of what that looks like. And so what we're going to do is we're going to actually create some elements and we're going to create some attributes that we can control. So we're going to keep our same for XML declaration down here. So we're going to keep the same invoices as our root element, invoice for each of our rows of the table. But now instead of having every single thing being its own element, I want to mix and match. I want to have some things be properties or attributes. I want some things to be elements and maybe even add some layers in here too. So the first thing to note is that now the order of my select list is important because it's going to process these in order from top to bottom. And what it's going to do is it's going to, whenever I put the @ sign before an alias, it's going to treat this as an attribute or a property instead of as an element. And it's going to modify, where it's going to put this attribute is whatever level came before it. So in this case, what came before it is this invoice, because that's where it's wrapping each row in. So number will become an attribute of invoice, as will date and as will status. But now when we get down to customer number, I did something interesting. I put customer / @number. What this will do is below invoice, it will add an element called customer with an attribute called number. And then below our customer element, we're going to add a first and a last name element that have the customer's first and last name. And I'll do the same sort of thing with the amount as well. So if I run this, what we're going to get back is a little bit more interesting than what we had before. So again, let me just kind of shrink down the other invoices, get them out of the way. And we can see now that our invoice now has 3 attributes that describe it. It has the invoice number, the invoice date, and the status. And now we've created this customer element with a number, so customer number 1. Remember, Lester Tester was our first customer. And now we've got elements for Lester's first name and his last name. And just like that, we also have amount, so we put the total, we put the total as an attribute, and we put all of the kind of the makeup information, what makes that total up, as elements. So the subtotal, the tax, the shipping, those are all elements below amount. So let me switch back to the query so you can see that one more time. So again, we modified invoice and added 3 attributes. So because they're at the very top of the query, at the very top of the select list, they're actually modifying this invoice element. But now once I declare another element by not putting an @ sign before it, it creates a new element called customer and adds to it a number element, an attribute. And then below it, it's going to add these 2 new elements as well, element for your first name and element for last name. So that's kind of how it's processing it. It actually does matter the order that you put these in. All right, so that's kind of cool. Let's take this example and let's move a little bit further with it. Let's go a little further with it. So I'm going to add in another section. I'm going to now nest my my 4XML queries, one within another. Because before we were only looking at the invoice header information. But really, to make this the most powerful, I want to have line item information too. So what I can do is as a correlated subquery, and what makes it a correlated subquery is one is it's the select query that's in my select list of an outer query, but what makes it correlated is the where clause references the outer table. So IH is my invoice header table, which is from my outer query. And that's essentially doing a join, more or less. And the reason I'm doing it as a correlated subquery is because I need to generate some XML first that I'm going to then bring into an element called line items. So I could have probably done that also by putting in here, root of line items if I wanted to. But the problem with that is I need to alias this column with something. It needs to have a name, otherwise it's going to generate like expression something or other, and it's going to look kind of ugly and not be what I want. So instead, I can control the name of the element and take out this root. So like I mentioned before, you can generate XML documents that aren't technically well formed, because if I ran, let's comment this out. If I ran just this correlated subquery without it being correlated and without errors, I'm missing a comma. So if I ran this subquery here, I'm going to see a bunch of sibling line item elements, and there's no root to this document, right? So there's no root element. Technically, it's not well formed, but it's still generated. I can still view it. I can still do all the nice things that this viewer lets me do with it. That's fine, but it's not technically a well formed document. And the reason I'd want to do that is because it's kind of like a stub, or it's a part of a bigger document. And then that's why I'm bringing it in under line items as an element in our existing query. So now if I uncomment this out and I run this whole statement, you can see that now I've brought in, here's my root element from before invoices, here's my invoice element. If I shrink this down, we have invoices for all 5 of our invoices. If I go back into invoice 1, we now see that we've got this big giant line items section that has 2 line items within it. So here's line item 1, here's line item 2. And each line item now has all the information that makes it up. It has the product number is 1 for Wacky Widget. The product number for the second line item is 2 for Rockin' Ratchet. And it has pricing information and pretty much everything I would expect for a line item. And that's all nested below my line items collection or element, which is nested below my particular invoice. So again, it's kind of I can represent a relationship of tables now with a hierarchy. So typically when you nest something below something else, you're representing kind of a one-to-many relationship or a one-to-one relationship in some cases as well. So that's how we can represent data in XML format using SQL. So let me go ahead and close this, do a little bit of cleanup, open our next demo. All right. So the next thing I want to talk about are how do we store XML objects in SQL Server. And so there's 4 objects in SQL that deal with XML. There's XML variables. So just like any other kind of a variable, I can have a varchar variable, an integer variable. We can also have XML variables. In addition, we can have XML columns in our tables. And both of those, they can be bound by a schema definition, or they can be unbound. And what that means is just like a table column, it can have a constraint on it that says this integer column has to be greater than 0, or it doesn't. Or it doesn't have a constraint on it, and I can put any legal integer value into that column totally fine. Same is true with XML, with both variables and columns. I can have it be unbound and just it's the Wild West, and whatever XML you want to throw at that column or that variable, it's happy to hold for you and accept, and that's fine. Or I may want something a little bit more structured, and say I'm storing these invoice documents, and I have a schema definition that defines them and validates them. Maybe I want to put that in as the maybe I want to bind that column or validate that column against that schema definition. That's also possible. And we'll take a look at both here in the demo. Then we have XML indexes, and I'm just going to kind of touch on these. They're a little bit outside the scope of an introduction here, but essentially you have a primary and a secondary XML index, and a primary XML index is a lot like your clustered index you would think of for regular relational data. But what the primary index really is doing is when you select from or when you parse an XML document in SQL, the first thing it has to do is parse or shred that document to a sort of intermediate format behind the scenes that SQL Server can better understand, and then it goes and gets the data that you want. And it does that every single time you would query from that column or that piece of XML in SQL. And then so you can see how if I'm doing that a lot, that's a lot of overhead to introduce to SQL. So instead, what I can do is, instead of putting the burden on the select statement, I can put the burden on the insert statement or on the update statement. So when I write the XML into my column or into my variable, if I have a primary index defined, it will shred that or parse that document at that time. So it will parse it when I'm inserting the row. So it's already there. It's already in that intermediate format. Thereby, when I go to query from it later on and select from it, that intermediate format already exists. I can skip that step and immediately go after the data that I'm looking for. Secondary indexes, they rely upon a primary, so you have to have a primary XML index in order to have one of the secondaries. And there's three kinds of secondary indexes that essentially target or help with different kinds of queries. Now, I'm not going to get into the details of all that. I have some notes in my demo script, and there's some good articles on books online that define it. But essentially, they help with different ways that you would be querying from XML. And there's kind of additional indexes that help out that primary index. And then there's also, again, just that schema collection object in SQL Server that stores your XML schema definition or your validation rules. So let's take a look at some of this. Oops. All right. So I'm going to create a new table in my database. We're going to call it XML data. It's going to have just an identity column on it just to keep track of things. And it's going to have a data column that is typed as XML. And so just a very typical, straightforward table, nothing too crazy about it. And what I'm going to do is I'm going to insert into that table, and in this case I'm using a kind of a subquery here so that I can get back as just a single row, nice and neat, exactly what I'd want to insert into it. So it's one column coming back as as my result. I'm going to insert in the XML we generated in the last demo. So we inserted that in, so we've now saved our XML data to the database, and I'll select it back just to prove to you that yes, we've saved in that document. It's now stored in there in row 1. If I click on it, there's the data we were looking at before. So again, that's we're now storing data unbound in SQL Server. I could insert really whatever I'd want to as long as it's XML into that column, and it would be fine. But what if I want to get a little bit more strict? What if I want to control what data is put in there? And that's where the XML Schema Collection comes into play. So to create that, we'll create an XML Schema Collection. We'll give it a friendly name. This is what I'll refer to it as later on when I'm altering my column. And we'll say as in just a big long string that is the actual schema definition. Now, I'm not going to get into the format of this or how it's set up. There are whole other articles and things that help you generate this. Again, it's a little bit outside the scope of this talk. But essentially, I just took a schema definition file and pasted its content in here as a string, and that allows me to create my schema collection in SQL Server. Once I've done that, I can now come over and alter my table, alter my data column, that's my XML column, and now we have this parentheses invoice data parentheses, and that's saying not only is this an XML column, it's also bound by the schema collection called invoice data. So we'll go ahead and alter our table now to be bound by that. And when it does that, it actually does validate the existing data against the schema collection. So we know that it worked and that everything is good because it didn't error out and fail. So that's a good sign. Our schema collection is succeeding. And to prove that to you, I can just run the same exact insert statement one more time. So let's insert another row with that same information in it, and now we should have 2. And sure enough, we do, 2 identical rows. But what if I try to insert some bad XML? So this is technically a valid XML document. It has one root node, it's called root, and a value of hello world. There's nothing illegal about that by itself, but it doesn't pass validation with our XML schema definition. So I'm going to try to insert that value into, or that document into our table as another row. And you'll see that we get a big red scary error. And it says declaration not found for element root, location /*root. Okay, well, what's that mean? What it means is it didn't find a definition for an element called root anywhere within our schema definition. And so it's going, that's not valid. I don't know what that means. It doesn't have a, it's not defined in the schema definition as something that's allowed in this document, so it has to be bad. And that's what it's saying. And so we can select from our table again just to prove that we didn't insert that record. We still have only 2, and we don't have that hello world XML in there that we tried to insert. As far as creating your indexes are concerned, it's as simple as just creating a primary XML index, give it a name on your table and what column has the XML data. That shreds all of the current data that's already in that column to that intermediate format. So now it's all parsed for me ahead of time. And then if I wanted to go forward and create our secondary indexes, I can go ahead and do that. And there's 3 different kinds, and they have basically the same syntax for the beginning part. So you would create an XML index, give it a name on your table, the column, just like we did before, using XML index. So that's the name of our primary index. So using our primary index. So again, you have to have a primary in order to have a secondary. But then we have 3 different options here. We can do for value, for path, and for property. And again, I'm not going to get into exactly what those mean. There are some quick notes at the bottom of the slide, but there's also some good resources on my blog about why you would want to use one over the other. But keep in mind when you're using XML indexes, just like when you're using indexes, typical normal indexes on regular data columns in your tables, that that there's a penalty to be paid, right? So if I index too heavily, I'm now causing a lot of performance impact on my inserts, on my updates, and possibly and probably on my deletes as well. So they're now taking heavy hits as they're modifying this data and updating all these indexes. And then if I'm not selecting very often, I'm not getting a big benefit there on reading the data. But my writes have now become really painful if I index a lot. But let's say that I'm inserting data infrequently and I'm reading it constantly. Then that's where indexes really shine. They perform very well in that case, because we don't care about the performance hit of updating the index at the time of inserting the data or modifying the data. What we care about is that we can query it quickly, and that's where the indexes are helpful. So it's always kind of a balancing act of how much is too much and what's the right kind of index and that kind of thing. It's always just this sort of juggling act that and your mileage will vary. So that's where having a good testing environment that has has data that's similar to your production environment will be very useful, so that you can test out how these perform. And then finally, we have, so now we've created XML. Now we've stored it in our database, and we've interacted with it a bit. How do we now query that database, or that data? How do we select that data out? Or how do we modify that data? So there's five methods in XQuery that allow us to interact with this data. I'm going to briefly explain them all, and then we'll take a look at them in a demo. So the first one is exist, and we give it a path that we're testing for. So we're basically saying, does the element or attribute that I'm looking for, given by the path, does that exist or not? And if it does exist, I get back a 1 for true, and if it doesn't exist, I get back a 0 for false. So you would basically say, do I have a path, I give it a path like /invoices /invoiced, where the invoice ID is 123. So do I have an invoice that's number 123? And if that exists, I'll get back the 1, and if it doesn't, I'll get back the 0. So that's useful for filtering. So it's useful for our where clause. The next method that we have is value. And value gives us back scalar values. So it will give us back a singleton value or one value for a given path. And it will type that as a given SQL Server data type. So I'll give it a path. So we'll say like /invoices /invoice bracket 1. So give me the first invoice slash number or something like that. And essentially that will give me the invoice number for the first invoice. And it will, I would give it a type, so I could say varchar 10 or int or decimal 18 comma 4, any kind of valid SQL Server data type. It's going to try to cast that data it gets back as that data type and present it to your query in that type. We'll take a look at that again in the demo as well. Node is where it gets a bit tricky. So node and query get a little interesting. It's going to be confusing when I explain it to you, but I think it'll make more sense when you see the demo. So node allows us to take one XML document or one row. So at this point in time, I have one row in my table that has a XML document that has 5 invoices, right? So I can give node a given root path. So I could say /invoices /invoice. And what's going to happen is node is going to look for all of the elements at that path. So there should be 5 of them, right? I have 5 invoice elements. I'll get back 5 rows for that. And so it creates kind of like a fake table that I can cross-apply or join onto that I can then use other XQuery methods to query. So value by itself isn't particularly helpful in a lot of cases, but I can only get back one value. So that's why I had to use like that first, give me the first invoice's invoice number. But I'd probably want to see all of the invoices' invoice numbers and have 5 rows come back, right? So I can use these two in conjunction with each other to give me back each invoice's invoice number. And you'll see a demo that's very similar to that. Query works a lot like node, to where we give it this path to get back all the elements from, but we can then give that back to the select statement. So it'll come back in our query results. So instead of using them with other methods, which node does, query allows us to bring that back as XML in a column in our select statement. And then finally, modify lets us make a change to our XML. We can do inserts, updates, and deletes to attributes and elements in our XML. So let's go ahead and switch back to our demo and take a look at that. So the first thing we're going to do is we're going to query from our table. Again, we have one row. It has one XML document in it with 5 invoices, right? But value, so the value method can only return a single value. So I have to use these bracket 1s all over the place to say, give me the first one you come to. Otherwise, it's going to just kind of arbitrarily pick which one it wants to use. So again, not particularly useful in this case. It's more important when we get to other demos. You'll see it be more powerful. And so it's called a method because it's a dot. Here's my alias for my table. So that's really saying XML data. Dot my column. So that's my data column that has my XML. Dot and then run this method on this XML is what this is saying. So it's the first two are things you probably won't need to do very often, but I included them in the demo script just as examples to reference. And these will give you the actual name of an element or the name of an attribute if you ever needed to find that out. So we're going to go to the, like, say we don't know we want to go 2 levels down, but we don't know what they're called, and get the name. So we can use asterisks as wildcards and say, go down 1 level, go down another level, go down another level, and give me back the first element and give me its name, its local name. So I would expect this to return the value of invoice, because that's the name of the 2 levels down that element. And then I could go below that and say, give me the first attribute. And in this case, I would expect that to be, I think, ID, or maybe number. I think it's number is the name of our first attribute. So again, not terribly useful or common things that we would do, but they're there for your reference. What is useful is if I want to go down, so here's how you define your path. So /invoices, that's our root element, slash invoice, that's our child below that, slash customer, that's an element below invoice, slash first name, and give me the first one it comes to. So this I think would be Lester. I'm pretty sure will be the value we get back. And again, we're typing all of these as a SQL Server data type. So you see varchar 10, varchar 25 for name is a little bit longer. This could be int, it could be decimal, 18.4, things like that. Any valid SQL Server data type goes there. And I can also do the same thing to get back an attribute value. So if I run this, we get back, sure enough, invoice, that's the name of our first element. Number was the name of the first attribute under the second, or I'm sorry, that's the name of our second element, or second nested level down. Number is the first attribute on that element. Lester is our first invoice's customer name, and delivered is the status of that first invoice as well. So you can see how you can get back singleton values. But again, I've got 5 invoices here. I probably want to see all of their data and not just the first one, right? And so that's where node comes into play. So let me get this out of the way. So what we do to see data for all of our invoices is we cross-apply the nodes method. So we'll do a cross-apply d, so that's our table reference, d.data.nodes. Give me all the nodes that are invoice elements. And you notice its alias kind of weird, right? So usually we're used to seeing like an alias be just like a letter. But in this case, there's kind of 2 aliases going on here. So that's the name of the fake table it's making, and invoice is the column in that fake table where it's going to put each individual element that it comes to. So we should have 5 rows in this I table with invoice columns that are XML that are each individual invoice. So then what we can do is now we can reference that. We can say, all right, go to that kind of fake table where it has 5 rows, 1 for each invoice in my one XML document, and now get the value. So now I've kind of exploded out from one row here to now I'm getting 5 rows down here. And so now I can get back each invoice's first name for the customer and each invoice's status using value. And that's a lot more powerful now than the value method had been before, right? So now I'm querying within an XML document multiple nodes at the same time and getting back their information. So again, that's way more useful, I think. Just to show you how query works, I can also use, I'll skip this query here. I can also do the query and give it a path, just like nodes we were doing. And this is essentially the result set that that nodes was working on. So it got back 5 elements, 1 for each of our invoices at that path. So that's essentially what node was doing, but then it was also presenting it to another method to then do additional things. Whereas query gives it back to me in my select list as you return this data to my user. And then finally, we have 2 more things, but and in addition here, we have exist. So I'm going to take that query from before where it had all those different invoices kind of parsed out, and I'm going to filter this. So now I'm going to look for invoices that have a customer first name of SQL. So again, my invoice is SQL Diablo. We're going to look for customer first name, and now if we put in bracket, is before we had like bracket 1, right? So that was actually a filter that we were applying, saying just give me the first one you come to. But what I could do instead is put a dot, which means my value or myself equals SQL. So now any customer first name that has element that has a value of SQL, it will be a match. So I'll get back a 1 from this for 2 of my invoices. The other 3 will be a 0. And so I just check for that 1, and that's how I filter out and get just my invoices. So now invoice 3 and invoice 5 have customer first name of SQL, and there's my invoices. And like I said before, I'm apparently a big spender. So that's how we can do filtering. So we've done selecting scalar values. We've exploded those scalar values out with node to get back a lot of values from our XML, and we can also filter by using exist. So we've got a lot of good functionality here. But what if I want to modify my XML data? Well, you would think it'd be as simple as just doing an update statement and setting our XML column back to itself with a modify, right? And that should probably work. I would think it would, wouldn't it? No, that doesn't work. It's not that easy. What we have to do instead is we have to actually store our modified XML into a variable, and then at that point, once we modify our XML in that variable, then we could, this is just a select statement because I don't want to actually be modifying my XML, but it could as easily be the same kind of update statement, where instead what we would have, let me paste this down here, you would have this kind of a syntax. So you would have, this would work at this case. But again, I don't want to be doing that because it'll break my demos, so let's not do that. So in this case, I'm going to populate my XML variable with just the first invoice. So essentially we're going to see this, just one invoice element, all of its information. We're going to be querying that, and we're going to be doing different things to that invoice. So the first thing I want to do is I want to add this element in my customer, I want to add a status to my customer. So the customer for this invoice, they can be active or maybe they can be deceased or something. So I'm going to add this whole element and its value into the customer element. And when I do that, you'll see it just kind of tacks it onto the end. So here's my customer element that I modified, and here's that status that I inserted, and it just threw it on the end of what was already there. Well, okay, that's nice, but what if I wanted to control where it went? I can use before instead of into, or after. And so before, now I'm going down one more level. I'm saying put it in before the first name. So this should now be the first element below customer. And sure enough, there it is now. It's the first one. Or I can do after, and after we just put it after the first name as now the middle. So now between first name and last name we have the status. All right, well that's pretty cool. I can add elements. What about attributes? Well, with attributes it's a little different syntax. So we do the insert that we were doing before, but we now have to use a keyword called attribute so it knows what you're adding. Here's the name of that attribute, and now the value of the attribute, we have to wrap that in these curly brackets with double quotes. So it's a little bit different syntax, but we're essentially saying now instead of adding status as an element like we did before, add it as an attribute that modifies customer. And so we'll do that. And sure enough, our customer now has this additional attribute called status. All right, well that's pretty cool, but what if I don't want to hard code the active, the value of that status? What if I want to kill off Lester Tester and I want to make it data driven so that it's coming from another variable? Well, I can do the same insert attribute status, but now in my curly brackets, instead of having just a double quote and kind of a hard-coded value, I now have this SQL variable, set of open parentheses, double quotes, and the name of my variable to get that value from. So it's now going to grab the value for this attribute from this variable that we've already declared. And so if I F5 this, we now see that poor Lester Tester has passed away. So that's pretty cool. That makes it a little bit more data-driven. So now what if we want to make some updates? Well, updates, you have to be a little bit wordy. So modify now asks you to do replace value of instead of just a simple update. And now we can give it the, we want to replace the value of the customer's first name. We're going to rename Lester Tester and make him Adam Tester. But you notice here it gets a little bit strange at the end of here. We've got this weird text open close parenthesis thing. So when we're modifying the value of an element, we're actually going to be referring to its value or its text. We could modify this, but it would rename first name to Adam, and we don't really want to do that. That's kind of weird. So what we really want to do is modify the value, and that's where this /text comes into play. And so we'll rename Mr. Lester Tester to be Adam Tester, and sure enough, there's our value. We can also do that to an attribute, and that works a little bit differently. So now we are actually going to be going straight to the attribute name, and we're not using this sort of text method here. And we're going to go ahead and just modify the invoice status and set it to be returned. And so now we see that our invoice status is returned. So we can modify things. All right, well let's kill off Lester again. Let's delete the entire customer element from our invoice. So to do that, it's real simple. We give it delete and we give it a path, and sure enough, We no longer have a customer element to be found, no first name, no last name, they didn't get orphaned, the whole thing is now gone. And finally, we can do that to an attribute as well, so we'll delete the invoice status altogether. Maybe I don't care about what my invoice status is, and sure enough, it's gone, no more invoice status. So those are the different XQuery methods we can use to interact with our XML within SQL Server. So just to summarize, we've got 3 different areas here. We've got our database objects, which are our variables and our columns that can be typed or untyped or bound or unbound. That's just another way of saying it, by a schema collection. That's essentially a set of validation rules, or think of it like a constraint on that column. You can use XML indexes. If you're going to do that, you have to create a primary index in order to create secondaries if you want to do that as well. You can create that schema collection, which is really your schema definition or your validation rules. So those are the objects within SQL Server that support XML. And then as far as interacting with it or expressions we can use, we have for XML, and that's how we query when we're querying relational data and turning it into XML. We tack on for XML with its parameters to then kind of transform our result set into XML for us. And then we have XQuery that allows us to query XML data and either check, we can do filtering with exists, we can get a scalar value with value, we can kind of explode out and do a cross apply and get a table of elements that are at a certain path, so that way we can use that with value or exist to get a lot more information than we could before. We can use query the same way we use node, but only it goes in the select list to return those anything at that path back to us in our select. And then finally we have modify that we can do inserts, deletes, or replace value of to modify our data. And then finally I have OpenXML because it technically is part of the product, however I don't recommend it. Typically when you see your performance problems, you're seeing them because of OpenXML. OpenXML, the way it worked was you would have to allocate space in memory to a document, pull the document into memory, and you would get back kind of a handle that references it, and then you do stuff with that handle and you query that document. And then you have to remember at the very end to deallocate that document and take it out of memory. And commonly people would forget to do this. And if you're pulling hundreds or thousands or more than that documents into memory but leaving them there, it's like a memory leak, and you're going to run out of memory and cause yourself lots of grief. Plus, it really wasn't all that fast at parsing documents or all that efficient, and it's not as easy to use, I think, as XQuery is. So I really recommend staying away from OpenXML unless you have no other alternative, and going with XQuery. So, resources. Feel free to visit my blog, www.sqldiablo.com/go/XML for your kind of one-stop shop. I have a lot of links out to other blog posts and books online articles about XML and how to parse it, how to generate it, things like that. I also have the download links for my session and my demos are out there as well. And any questions?
We've got quite a few. Do you want to look at them yourself, or do you want me to just feed them to you?
Yeah, I can try to look at them here. Maybe. I'm not sure that's working for me very well.
Well, I'll just do it. Okay. And some of these may have been answered, may not have been, but I'll let you make that determination. What's the difference between a node and an element? And then also this a follow-on, could you please explain again what is an XML node? So they're both about the same.
Okay, sure. There really is no difference between node and element. They're just synonyms for one another. And essentially a node or element is it's the entire, sorry, that got in my way. GoToWebinar got in my way. So it's the entirety of something at a given path. So if I said give me the node or give me the element at /invoices/invoice, you would get back what I drew a box around. So that would be the value that would be what you would get back. And its value then is going to be what's between the starting and ending tags. So it's the value of that invoice element would be these two elements or these two nodes. Node is more of a programmer way of referring to this. It's more with the document object model, or DOM, refers to it, I think, mostly as nodes. Element is kind of the official way to call it, but there really isn't a significant difference or any kind of a difference for practical purposes between those two names. They're just synonyms.
Okay, this user wanted to know what about type in quotes at the end of the for statement? What does it do?
Type in, oh, okay. Type at the end of the for XML statement. That was essentially telling it to return me back what I'm going to refer to as strongly typed XML. And so what I mean by that is when I get back my results set, I want it to be actual XML data that my query window understands, or that my application understands as XML. If I leave this off, it's going to return back to me string data. That what's interesting is now SMS is smart enough to see that and still treat it like XML, but really it's returning me a string versus an actual XML typed data. In addition, though, it also there are some parameters around how it controls the formatting of your XML. Again, it's a bit outside the scope of the talk, but you can research in books online for XML, and it will talk to you. It will talk to that question as far as what the different parameters are here that it takes and what they mean.
Okay, the next user wanted to get a list of good books for XML.
Oh, that's a great question. I don't have an answer for you, but I will research that a bit, and perhaps I will blog about it.
Okay. And does the correlated subquery?
Sorry. I do have actually kind of an answer to it, but it's not the answer you might be expecting. Is W3C Schools? It's basically the consortium, that the World Wide Web Consortium. They're the kind of the driving force behind this standard. They have a really good website that walks you through all the definitions that I went through of what makes up XML, and also of what some of the XQuery methods, how they work and what they mean from the standard perspective, like agnostic of whether it's SQL or an application or Java or whatever it is, that can be helpful. So that's a good resource. It's W3C Schools. Just Google that. You'll get their website pretty quickly that way.
Okay. This user wanted to know, when you were talking about correlated subqueries, does that negatively affect performance?
It absolutely can, for sure. This is going to make it more like a rebar operation or a row by agonizing row. The unfortunate thing is that there's not a good way to do this, or I don't know if it's even possible to do this as an actual join, because of having it be, because we're generating XML. If it were just relational data, it would make way more sense to do it as a join than a subquery or a correlated subquery. But again, because we're returning back XML that we're kind of encapsulating in another for XML, this is the way we have to do it, as a subquery. But yes, there is a performance impact to that.
Okay. How would you change the XML file for an SSIS package and save it?
Change in XSL or XML?
XML, I'm sorry.
That's all right. I'm not sure I understand that question. So whoever asked that, shoot me an email or tweet me on Twitter, and we'll talk. I'm not sure I quite completely understand.
I wasn't sure either. That's why I was just reading it out the way she said it. Okay. Slides to some user. I can tell you this. From questions and comments, you've done a great job explaining this, because I haven't had this many people come up and say, whew, I mean, I finally understand some of these things now. You took a real hard topic and explained it simply, and that's the type of speakers we want. This user said that there was quite a bit of stuff about XML on the 70-461 query test. So that's just something.
Right. Yeah. Right. I presented this session at Cleveland SQL Saturday back in February, and I got a huge audience that I wasn't expecting, and probably 75% of them were there for that reason, was because of all the XML on those tests, which was news to me. I didn't know that, so I'm very surprised to hear that. But you know, this is good stuff to get you ready for that exam for sure. That I got a lot of thank yous there too. So you know, feel free to take a look at the demos. You know, play with them at your leisure and kind of you know, tweak them, change them, and just get a good understanding for how they work.
Okay. This user wanted to know how to update multiple records.
How to update multiple records. I'm going to say that's probably outside the scope of what I can answer in a few minutes, so I may blog about that.
Okay.
If you have specifics, feel free to email me, and I'll try to answer your question more directly.
If there's some like this that we can't answer, I'll send you a list of the questions along with contact information for the user, so if we don't get them answered, you can talk to them, and then also they can come to your blog. This one is pretty detailed. We have package software in the SQL Server database. The XML data is stored in image data type columns, not in XML data type columns. This is confusing for me. How is this different? How do I make a start with XQuery in this scenario?
Gotcha. Yeah, that's a little strange that they're doing that, but fortunately for you, I think, you should just be able to cast that image column to XML. So I think if we did so if we did something like this, to where I'm essentially giving it, this probably will fail because let's see if it succeeds. Yeah, it does. Oh, nice. Yeah, so I don't have a quick way to test this, but I would assume that you could cast that data to the type of XML. So you could just do like select cast image data as XML. Oops, that's CML. As XML from table. You know, you could do something like this, and then now you can start to apply your dot methods to this. So now, since it's as XML, you can do, you know, dot value, and then have you know, your path here, and you know, your type, you know, varchar 10, and you know, all of that kind of stuff. You know, you can start to do that. I didn't properly form that, but you can start to do those kinds of things just by casting that image data to XML. That should work for you. If you have problems with that, again, shoot me an email. I'll help you out offline.
Okay, that's about it. I wanted to go ahead and give out the $25 gift card from Amazon that goes to Amir Khan. PASS will be getting in touch with you. We'll send them information. So, and next month we'll have, again, like I said earlier, Grant Fritchie with identifying long-running queries. Everybody sign up for that. And thanks again, Adam. This was a great way to summarize a difficult topic, and we really appreciate it. Hopefully you can come back sometime. So,
I'd love to. It was fun.
hey, thank you. Bye.